Hey students, we're about to go over intermolecular forces. Now in this particular unit, some of these concepts have been historically difficult for students to grasp. So as you're working through this information throughout this unit, if you have any questions, reach out as soon as you possibly can so I can kind of clear up any misconceptions that you may have right at the beginning. Okay, I don't want to wait too long and then it's hard to kind of unwind everything that you're mixing up in your head. In order to be really successful at intermolecular forces, there's a few things that we need to recap from last semester. So the first thing that we're going to recap is Lewis structures. So I've put a little brief description of how to draw your Lewis structures again. We're going to do some practicing. So with CO2, we'll start with. First thing you always want to do is count your valence electrons. So CO2, carbon has 4, oxygen has 6 times 12. Sorry, not times 12, I'm getting ahead of myself, times 2, which is 12. So we have 16 total electrons. We're going to put our carbon in the center, connect everything to it. Remember, each line counts as a pair of electrons, so we just drew 4 electrons there. I'll put my other O there. Now, when you put your dots on, you put them on the outside atoms first. And I just used 12 more electrons, so I have no more to draw around my carbon. So that means that you're going to have to erase a pair. Whoopsie, I erased too much. Let me draw those back here. So that way you can draw a double bond between the carbon and the oxygen, but the carbon's still not happy. So we're going to have to erase another pair and draw another double bond here. So we've used 2, 4, 6, 8, 10, 12, 14, 16 electrons, and everything has 8 electrons around it. Okay, let's take a look at PF3. Phosphorus has 5 valence electrons, fluorine has 7 times 3. So that means we have 26 total valence electrons to work with. We're going to put our P in the middle, connect the F's to it. That means that we've drawn 6 electrons. We have 20 left. We're going to go ahead and put the dots on the outsides. You got to put the outside atom, make the outside atoms happy first by getting everything up to 8 valence electrons, except for hydrogen, of course. So we just used 18 electrons. We've got 2 left. Those go on the central atom if you have any left over. And now everything has 8 valence electrons around it. And everything is happy. If we take a look at the SO3, S has 6 valence electrons, O has 6 times 3, it's 18, so we have 24 total electrons. We're going to put S in the middle, connect everything to it with a line, and that means that we've used 6 electrons. We have 18 left. So remember, we're going to put them on the outsides first. We put 6 dots in everything here to get those up to 8. We've just used 18 electrons. We have no more electrons left, so we cannot put dots on the S. So remember, if we have to make our central atom happy, we erase a pair. Sorry about that, I erased a no. And you're going to draw a double bond here. Okay, we're not going to worry about resonance or anything like that right now because that's not really important into what we're doing with these intermolecular forces. Okay, but with this SO3 molecule down here, we have 8 electrons around each oxygen, and we have 8 electrons because we have 4 lines around this sulfur. All right, I'm going to let you draw that CH3 Cl by yourself and make sure that you guys can draw that molecule correctly. The next thing that we're going to recap is the bond polarity. Okay, bond polarity. So remember, we've got polar covalent bonds and we have nonpolar covalent bonds. Most covalent bonds are polar. Let me say that again. Most covalent bonds are polar. Okay, that means the electrons are not shared equally, and we're going to have dipoles to indicate that there's a partially negative end to that bond and a partially positive end to the bond. There's only 2 types of nonpolar covalent bonds. That's when something is bonded to itself, or if a carbon is bonded to a hydrogen. So if it's not one of those two things, we're going to list it as a polar covalent bond. So let's go ahead and draw these things here. And I'm just going to go ahead and draw this quickly for us. So when we look at this NF3 here, this is how it's going to look. When we're talking about the bond polarity, we are talking about the bond here. What's connected to that bond? We've got a nitrogen and a fluorine. That means that this is a polar bond because it's not bonded to itself and it's not a carbon bonded to a hydrogen. This other one is going to look like this. You're going to notice that there's no dots around it because I've got hydrogens and hydrogens don't get dots. So we have two bonds here. We have this bond here and we have these bonds here, okay? This top bond between the carbon and hydrogen, that would be a nonpolar bond because carbon is bonded to hydrogen. This bond down here would be a nonpolar bond because carbon is bonded to itself. So both of these here in the C2H6 would be nonpolar bonds. Then the third thing we want to recap is molecular polarity. So we have polar molecules and we have nonpolar molecules. Polar molecules, remember, have to have either lone pairs on the central atom or they're going to have different ending atoms. The outside atoms are not going to be the same. Nonpolar molecules mean that there's no lone pairs and the ends are the same. So let's quickly draw this up here again. Maybe I should have left this up here for us. So remember our NF3 here. Now remember, this time we're talking about the bond polarity. We're talking about molecular polarity, not the bond polarity. So the overall molecule itself. So the fact that NF3 has this lone pair right there makes this a polar molecule. It's a polar molecule because it has lone pairs on that central atom. So let me get that C2H6 up here again. So we can take a look at this. So as you can see, you're looking around the central atoms. There's no lone pairs around the central atoms, and all of those outside atoms are all hydrogen. That means this one is a nonpolar molecule. All right, so those were the three topics that we wanted to recap for this particular unit before we get into the new stuff. So if you have any questions about this stuff from the last semester, please let me know as soon as you guys can because you're really going to have to be able to use this semester. Thanks.